This is part of our XP Live educational program. All of our previous webinars have been recorded and you'll find them available on the link that you can see on screen there on the XP Solutions website. We anticipate that this presentation will be less than an hour in duration, and the topics we're going to cover will be the significant enhancements to XPSWM and XPSTORM, which we'll cover in three categories: 2D modelling, GIS enhancements, and modelling and results. I'm going to describe some of those enhancements and then I'll use some typical models to demonstrate some of these new capabilities. As Sudesh mentioned, we'll have a question and answer session provided at the end, so you've got the opportunity to ask your questions then, but feel free to do so throughout as well. So you may be aware we normally do an annual release of the software. The release due out shortly is XPSWM 2012 and XPSTORM 2012. In between these annual releases, we'll also do some maintenance updates. These are known as service packs, so look out for those on the website and via newsletters as well. You'll see all of the changes that have been made listed in the changes.txt file. This file's installed when you install the new version, and it's also available on our website. The annual release, such as 2012, comprises user requests, maintenance items, and enhancements, and often this incorporates new features. However, the maintenance updates will normally just be issues that have come up from service requester through support or our own internal testing. You'll find all of the maintenance updates and full version installers are available from the downloads page on the XP Solutions website, so feel free to go there and you can check that you are running the latest version at any time. So we'll start with the 2D modelling enhancements, and firstly I'll talk about changes we've made to 2D infiltration losses for the direct rainfall option. You'll see when you get the new version of the software that the 2D land use category has some changes to the form. At the bottom of the form here, we've made a few changes to the infiltration section. So you now have the option to specify rainfall abstraction as an initial loss and a continuing loss, with infiltration now referring to a slightly different feature which allows you to also specify a soil type. If we were to click on the soil type button there, we can add different soil type categories, and we can then specify details for those soil type categories. So this becomes part of the global database, which hopefully some of you are familiar with using. The soil type can be set up as a user-defined or a USDA soil type, and within that there's the option then to specify the infiltration method for that soil type. So with the US soil types we have some built-in parameters which can be used with the green amps method, or with the user-defined option we can enter those soil parameters that you can see on the screen there now. We've also added the ability to specify a depth varying roughness value. So on that 2D land use form where we have previously entered our Manning's N as a constant value, we can now enter a range of roughness values depending on the depth. This is particularly useful for the example on the left hand side of the screen, which shows a cross section of a vegetated channel. If we were modelling this in a 2D scenario, we would want to vary the roughness to reflect the fact that at the bottom of the channel we have no vegetation, and as the water increases we have some quite dense vegetation on the sides, so we could demonstrate that by doing a depth varying roughness, as you can see on the right hand side. We'll show you all this in the software live. We've got a new feature in the 2D section of the software as well, which is 2D Flow Constrictions. This provides the ability to add an obstruction to the 2D model. So to take account of a range of things like bridges, pontoons, and also what we're calling user-defined layered flow constrictions. This provides the most flexibility so that you can set up any obstruction. This might be used to represent a complicated bridge or to represent a building or something else that is going to interrupt the flow. So we can see the diagram we've got here shows a simple bridge deck where we have an invert along the bottom and an obvert referring to the underside of the bridge deck. So we can have this entered into the form on the right hand side and specify what blockage we've got through that bridge, if any, and also what energy loss is occurring there. For a more complicated bridge, we may want to use the layered flow constriction option. This diagram shows a bridge that has a pillar in the section where we would expect the water to flow in a low flow condition. We've then got a solid section, which is layer 2, which could be representing the road deck. And then we have layer 3, which has a number of railings. So again, we've got a different blockage factor here. So in this example, which I'll show you how to set up in the software, we may want a 10% blockage for layer 1 with quite a small energy loss coefficient. Where we've got layer 2 that's 100% blocked, we may want a much higher energy loss coefficient, and for layer 3 the railings again will set the blockage and energy loss coefficient appropriate for that setup. Another improvement in the 2012 release is adding greater flexibility with the 1D, 2D links. So currently we have several options to create interface lines where we have open channels, or to connect manholes and culverts to the 2D grid cells. In 2011 that's limited for those manhole and culvert invert connections, so that water can only connect to one cell. This can cause an issue where you have a wide culvert that's actually wider than the number of grid cells you have. So now in 2012 you'll have the option to specify an interface line to more accurately represent the width of a culvert in that scenario. That means we have a choice. The interface line can either be a head or HX interface line, or a flow or SX interface line. The head interface lines would be more commonly used for situations such as shown on the bottom half of the presentation, where we have an open channel and we set the interface line along the whole of the edge of that open channel section. The SX line would be more appropriate where we're connecting a 1D node, such as where a culvert discharges onto the 2D surface onto multiple 2D cells, so we can draw that interface line and spread the water appropriately. The 2D job control has also had some changes made. It's now possible to specify separate time intervals for map outputs, time series outputs, and mass balance outputs. So this allows you more flexibility in terms of the results you're creating. There's a range of new 2D map results types which can be selected. These are shown on the screenshot here, and we'll have a look at them in the software. It's advisable to only check the boxes for the ones you want to run, as these will only generate results if they're ticked in order to save on computation time. So I'll go ahead and go into the software and show you some of those features. We've created a file here set up to run a 2D analysis, and you can see that we've got a developed area in the center. We've got some housing here. Coming along this section, we've got nodes and links to represent a channel, and we've also got manholes and links in the developed area to represent the flow getting into the underground network there. The vegetated channel continues downstream after it discharges from a culvert the other side of the development. What I've done in this model is I've already set up some 2D land use layers, and I want to show you some of the new features in the 2D land use option. So I can access this by going to the configuration menu and by selecting global data. I've got a whole range of database types here, and I'm going to select the 2D land use database. So these are the 2D land use categories that I have already set up in this model. First, I'm going to click on the option for pasture and click on the edit button so we can see the details in this form. So at the bottom half here, we've got the new infiltration section. If I click on the soil type here, I can then see from the global database again what soil types have been set up. I've set up these soil types so that I can easily show you how to edit them. If I wanted to add another soil type, I would simply type it in the box here and click on Add. I'm going to edit the sandy loam soil type, and we can see that this is specified as a US soil type. So these are built in to the software, these US soil types, and so are the soil parameters associated with them. If I wanted to use a user-defined soil type, I would be able to click this button and specify these parameters myself, and then the infiltration would be calculated from these parameters. I've then got the option to specify the infiltration method, and with the green-amped method we specify a maximum ponding depth. With the initial loss and continuing loss method, we enter the initial loss and continuing loss here. Okay, I'll just close those forms and go back to the 2D land use global database. Now I'm going to open the vegetated creek 2D land use by clicking on Edit and show you the enhancements to the Manning's roughness section. At the moment we have a constant Manning's roughness specified of 0.09. This would be fine if our channel had a constant roughness throughout the whole of the depth, but if we click on Variable and Edit Curve, we can see that we have the option to specify the depth and the roughness varying in the table here. So in this case, much like the diagram I showed in the presentation, we can actually increase the roughness with depth as if the sides of the channel were more vegetated as the depth of water increased. Okay, I'll close this form, and now the other thing I want to show you in terms of model setup is the new feature, which is Flow Constrictions. This can be used to represent obstacles, and in this case at the upper end of the catchment I've got the vegetated channel here, which is actually going underneath the road. So there's a bridge here which may have an effect on the 2D flow, because the water going underneath the bridge might be affected by energy losses, and it might be affected by intrusions from pillars and so on associated with the bridge structure. I've already drawn a flow constriction here. It's very simple. If you want to draw another one, you simply click on the flow constrictions layer, select either the polyline or the polygon tool, and draw the polygon onto your model. I'm going to look at the data in this flow constriction already. So I right click and select edit data. This is set up to reflect the diagram of the bridge that we showed. So I've selected a layered structure type. I could also do a simple bridge deck or a floating deck to represent a pontoon or similar. This layered flow constriction can be used for a range of different flow constrictions, in this case a bridge, and it can also have a number of different layers. So we've got 3 layers here, with layer 1 having a 10% blockage and 0.070 energy loss coefficient to represent the fact we just have one pillar in our bridge. The invert level here represents the underneath of the channel that goes under the bridge. We could have this as a constant invert if it was a flat surface, or we could also specify a variable invert. The same for the obvert. The obvert for layer 1 represents the upper side of the bridge, so effectively the underneath of the bridge deck. And again, we can choose if that's constant or variable. For layer 2, because we use the obvert from layer 1 for the invert of this layer, we only have to specify the obvert. So we have 100% blockage here to represent the road section and a very high energy loss coefficient. And then finally layer 3, we have a slightly higher energy loss than for the layer 1 section and a 25% blockage to represent railings above the road section. So once that's set up, we would then be able to run the analysis and see the effect of this bridge on the 2D flow. In this model, I also have a situation where I've got a culvert that's discharging onto the 2D grid. So I'm going to use Control F to find culvert 3 in my model. It's a link, and we can see it's right here. If I open the link culvert 3, I can have a look at the data. It's a circular culvert, and we can see that it's 2 meters diameter in height. However, if we go to the conduit factors, there are 3 barrels. So this means the width of this culvert in total is 6 meters wide. If I also take a look at the node downstream, then I can see that this is linked at the invert level to the 2D terrain. So we've got water discharging through a 6 meter wide culvert essentially, and that's discharging at the moment onto one grid cell directly above the node. If our grid cell size is less than 6 meters, then we're potentially forcing a lot of water into a very small area. So now with the 1D 2D connection interface option, I can specify a line, so I can spread that flow out over a more realistic space to represent the 6 meter width. I'll tick on the 1D 2D interfaces layer here, and we can see I've already drawn a line. Again, we have the option to draw this as a polyline, and it would be very simple to do that. We also have the option with the 1D 2D interfaces layer to import this from a GIS file. So if we had the width of that culvert in a GIS file, we could import that in there. Once I've drawn the interface line, it's important to select Edit Data and check that I have specified the correct 1D 2D interface line type. As I mentioned, the head interface line is used generally for along the edge of open channel sections, and the flow interface line is used where we're connecting flow either from a manhole or a node where we've got a culvert, such as in this situation. So I've got the flow interface line selected there. At the moment, that's not connected to the node, so I need to add a connection line to show where I want the flow to interact with my 1D model. Again, I can draw the connection line. I'll just delete this. I'll use the snap tool and use the polyline tool and then draw from the node to the interface line, and now they're connected. I only need one connection line when I have an SX flow interface. So finally, in the model setup options, we'll have a look at some changes to the 2D job control. We're going to select the configuration menu and the job control and have a look at the 2D model settings. On the general form, we have only a couple of small changes, such as the ability to do an additional mass balance iteration. Largely the rest of this is unchanged. On model output, this is where we can now specify the different results intervals. So we can have the map output interval, the time series output interval, and the mass balance output set up for different time steps. For our new map results types, you can see we have a large range of options available that can now be mapped. When we run the analysis, results will only be generated for the options we've got ticked on here, so probably best if you untick the ones you're not going to use so you can save on computation time. Hazard is becoming very important, so there's a lot of hazard categories in there. We're going to keep the hazard velocity times depth and one of the Australian categories for hazard ticked on, and also I'll untick the current number and leave the mass balance options on. The rest of the 2D job control form doesn't have any changes. So that's the end of the 2D model setup demo. Now we'll go back to the presentation and have a look at some of the results options. So for 2D model results, we've added a new feature, the 2D simulation summary. This means that we can report some of the key information from a 2D model run at a glance. It allows you to do a quick quality assurance, quality control assessment, so that you can see a lot of data about the 2D model in one place. It shows you in the top half of the form all of your input data, so you can see what you've set up in the 2D model, and then in the bottom half of the form we've got a selection of graphs which are really useful for checking the health of your 2D model, give you information about the run that should help you decide whether you're happy with the results. The 2D map results that we just showed ticking on in the job control can be displayed on plan. So we'll show you how you can change from one set of results to another. We've got the option to export these results as well at the current time step or the maximum where that's available to GIS file formats, so that you can use those outside the software as well. We also have now added the water elevation from the 2D analysis to the cross-section tool. You might have used the cross-section tool previously to have a look at the tin, the digital terrain model, to get a feel for the fall of the site and maybe cross sections of channels. Now we've added the 2D water elevation to this cross section tool, so you can see that displayed. The grid cell size is quite important, and what level of detail you've got in your DTM here, because obviously the display can only use the data that's available. So we'll go back to our job, and we've now got the same job here, but we've got results. I didn't want to show you looking at the time analyzing across the screen, so we've already run the analysis, and now we can have a look at the results on here. First, we'll have a look at the 2D simulation summary. Now a really good place to start once you've run an analysis. If we have multiple scenarios or multiple storms, we'd be able to look at all these on the same summary by using the drop downs at the top here. But at the top of this form, I can just quickly scan through, and I can see what I've input into this model and just look for anything obvious that I've missed. It also tells us if there's any warnings, any checks that happened, and so on within that model. On the bottom half of the screen here, we've got the graphs that I mentioned. So it tells us the change in volume, the flows in and out, and also a really useful one, the cumulative mass error. So in this case, if we look at this graph, we can see that our cumulative mass error throughout the simulation time is always less than plus or minus 1%. So that would help us to decide that we were happy with the model or not. If I close that form, we can have a look at the 2D map results. So at the moment, we've got the water depth ticks on. I can either view the maximum water depth, or I can use the animation and show how that changes throughout the animation. I'm just going to go to about halfway through the storm and show the water depth there. If I right click on the 2D map results, we can see that the options that I ticked on for the analysis are now shown in black text, and I could select any of these. So we can look at the hazard category, see the velocity times depth, and how that varies, where people are going to be most at risk from the water, or any of the other options. I can export these either at the current time step or at the maximum level if a maximum is available, and look at them individually in turn. I'll switch back to the water depth so that I can show you the section profile tool. So the section profile here I can select, and if I now draw a cross section across this area, we can see I'm going across an area where we've actually got some shallow flooding over the housing there. Then I've obviously got quite a lot more water, deeper amount of water in the channel section, which is part of the tin. And then on the other side, where we've got this playing field, there's water collecting in that area before the land rises again to the right hand side. If I wanted to always look at these results in the same area, what I could do is set up a water surface profile. So if I right click on here and define a cross section and draw another one, call that profile 2, then I'd already set one up previously. Now I know that I can always look at these two. If I make any changes to the model and rerun, I can see these in the same place just by clicking on the graph option. So there's two ways you can access that same tool. So there's some other enhancements to the software in the 2012 version, which we'll talk about first, the GIS enhancements. We've added the ability to export the 2D map and vector results from water level lines to the Esri ASCII grid format, so that's now available as well. And we've also got a new GIS export button added to XP tables. So this is a really useful tool for exporting node and link data and attributes to the GIS format. It allows you to access this form where it will default to including just the XP tables data, but you can actually keep adding variables to this as well. It's worth just being aware that the shapefile format does have a limit to 10 characters for the names, so you will have to amend some of the default names used in XP when you do that. But it's very easy to show you how to use that in the software. If we go back to the model setup option, and I'll just zoom out here. So we can see we've got nodes and links set up across this urbanized area. If I right click on the nodes option in the layer control, I can export to GIS from here, but this just creates the basic node data, the name and the X and Y location. I could then set up my own table as we normally do in XP tables. But if I've already got an XP table set up, so we've got link tables, if I click on node data, if I've already got this data set up and I want to export this data to GIS format, I can just click on the GIS button and access this same export form here. But now I've got all the table titles that I've already set up included here. If there's anything else I need to add, I can just do that simply here. So let's say we want to add the ponding type. I can add that on the bottom here. I need to select where I'm going to save this GIS file, so I'll just save that into the XPS directory for XPSWM 2012, and we'll say call it node export. I could use the map info file format, which means I'm not limited on the number of characters, or if I choose the shape file format, it just means I need to edit these so that they're all less than 10 characters. I'm not going to try and abbreviate these. So then once I'm happy with my names and I've got all the attributes there, I can just click on export. It tells me how many nodes it's exported and whether there's an issue with any invalid nodes. And then if I click OK to this message box and close the XP tables, now if I wanted to, in the GIS, I would be able to access that file and load it back in. Okay, so back to the slideshow to look at some of the other modelling and results enhancements. We've added time sensors to the real-time controls feature, which is a really useful improvement if you're doing any modelling with stormwater harvesting that needs pumps switching on and off for irrigation purposes. So it's now possible to set up a real-time control that's switched on certain times of day, months, days of the week, or possibly simulation times as well. So this we can show you in the software how to set it up and how you would use that option. There's also the ability to show the overflow, the cumulative overflow from a node on a graph, and that's added to the review results option. And then that depth varying roughness that we can access for the 2D land use category can also be used for the 1D channels as well, so I'll just show you where you can access that. We've added a new enhanced text editor to the installation, so those of you familiar with reviewing results will be used to looking at the output files in Notepad, and now we've got Notepad++, which means that you can add a compare plugin to allow easy results comparisons. If you go to the Edit Application INI file settings, you can change that text editor to another text editor if you want to use that text editor. And finally, we've added the ability to show 1D flood mapping. So this is useful if you don't have a integrated 1D, 2D flood model, but you just have a pure 1D model. You can actually show flood extents that may be possible from that 1D channel on the maps, and you can animate that in the same way you can animate the 1D, 2D setup as well. So we'll show you how to do that in the software too. Okay, so back to the software, and we'll start by looking at a real-time control model. I've already set up this model so that on this link 4, we've got a pump set up. What we want to do at the moment, the pump is switched off. So we've got flow going down the main channel, and we want to see what would happen if we were to switch this pump on at certain times of day, days of the week, and so on. So typical situation might be that you want to water a parkland area from a stormwater harvesting tank, but you only want to switch that on overnight because, of course, switch it on during the day and all the water is going to evaporate. So within the configuration menu, we can select real-time control. Those of you not familiar with the real-time control form, this section here is where we add our real-time controls and our sensors, and then the form is split into two sections. The bottom section shows the real-time control details, and the top section shows the sensor details for whichever one is selected. We could add a new real-time control very easily, and then we could add new sensors to whichever control is selected if we wanted to set up a new one. I'll show you what's already been set up for this real-time control. So we've selected from here the control type as a pump. We could select any other feature that was in our model for the control. It tells us the name of any of these features we've got available and which parameter we want to edit. So in this case we want to increase the flow rate through our pump. The ramp on, ramp off section allows you to specify a number of minutes that this is occurring over. So this means that we can set up probably something more realistic, that the pump or whatever it is isn't going to switch on and off immediately. It's going to take a little bit of time. So we've got 5 minutes set up here. And then we're going to enter here the minimum value, what we want to increase our flow rate to. So we're increasing our flow rate when we switch this on to 1 meter cube per second, and then we'll have it return just to a minimal flow rate of 0.1 meters cubed per second. The easiest way to think about these real-time controls is that once we've set up the real-time control and the sensors, when all the sensors are true, the real-time control is going to happen. So the control is the action, if you like, and the sensors are what tells this action when to happen. So our pump's only going to switch on if all of these sensors that we've set up are true. The sensors are set up so that they use Boolean logic for the relationship. So in our situation, we're using the AND set, character between each sensor, which means that we want all of these sensors happening at the same time. So in this example, we've set up that if the month is greater than or equal to February, and the month is less than or equal to April, if the day is greater than or equal to Saturday, and the day is less than or equal to Sunday, and if the time is greater than 2 AM or less than 5 AM, then we want our real-time control to switch on, and that means our pump is going to turn on. So these time parameters are our new sensor types added in 2012. So we could also use the simulation time if we didn't have such a long time series, but we knew exactly when in the simulation we wanted something like this to happen. This example actually has a year's worth of rainfall data in it, so we don't want to click go and run the analysis. I've already run the analysis and we've got the results available here. So we can see straight away that the flow is very low, 0, and then we get an increase in flow up to 1 meter cubed per second. We can tell from the axis at the bottom that this is only being switched on from February to April. If we just zoom in there, we can see as soon as it's February, March, April, it's on. Once it gets to May, it's no longer on. If we zoom in again, we can see the days of the week. So as we set up, if it's Saturday, greater than Saturday or less than Sunday, essentially if it's the weekend, our real-time control is switching on. And then if we zoom in again, we've got 2 AM for the start time and 5 AM for the off time. It actually takes an hour to switch on and off in this case because our time step is an hour, just because we had a year's worth of data running there. So a useful tool there for pumps and other operations that are time sensitive that you can now set up in real-time control. I'm going to go back to the 2D model results file, and I'm going to show some of the other results we mentioned. So I'll use Control F again. This time I'm going to find manhole number 12. And if I zoom in here, we can see that there was some flooding occurring in this area. And if I just step back through the analysis, it looks like it started from this manhole at 42 minutes. So what I should be able to see is on our results graph for this manhole, I should now be able to see the overflow option. So I'm going to click on Review Results and show you the graph. We have the stage here, the water level, and we now have the cumulative overflow displayed with the pink line as well. We can see that this is starting roughly about 43 minutes and that the overflow start coincides with the elevation exceeding the surface elevation, so that would be what we'd expect. If you wanted to remove this from the graph, you can select the icon at the top of the toolbar here, Properties, and you can untick the overflow option. I'll close this form and just go back to the plan view. If I now select one of our links in the channel, this has been set up as a natural section. If I click on the natural option and then click on edit for the cross-section details, I've got the addition of the depth varying roughness. So this is the same form for our 2D land use category, just showing you where you can use it in a different way for the 1D natural channels. Finally, I'd like to show you the 1D flood maps option. I've got another job here, so this has been set up. We've got a channel section running down here that's discharging to a river. So all of these sections have been set up as 1D channels. We've got a bridge, and a culvert. And it's very simple to use the 1D flood maps. It's just a case of whether this is ticked on or off in the reporting section of the layers. So with the 1D flood maps ticked on, again I can use the maximum option at the bottom of the form here, or I could animate this as I would if it was a 2D flooding as well. I'll just pause that and go back to the maximum. So we can see the extents of the flooding, and in this area obviously that's spreading away from the channel. It is worth being aware that although this is a useful tool for 1D models where you're not running an integrated 1D 2D model, it does have some limitations compared with the 1D 2D integrated approach, and you should just use a bit of caution, particularly where there's significant meanders in the model, and just consider whether a 1D 2D approach is going to be a better option. So thank you for listening to our webinar today.